we're going to start taking a look at how to take the negations of our universal statements, our existential statements, and the universal conditional statements. The first thing we should do is identify the forms. And remember that if we have for all x in domain D, q of x, remember that was a universal statement. So the negation, all we're going to do is we're going to flip the quantifier. So it's going to become an existential statement, and then we're going to take the negation, right? And of course, we should probably replace, every time we have an existential statement, we should replace the comma with a such that. For an existential statement, to negate it, remember the original form is that there exists x in domain D such that q of x. Well, just like we did above, we're going to flip the quantifier. So that's going to become a for all. And instead of such that, we're going to replace that with a comma, and then we're going to negate the predicate, so not q of x. Finally, for one of these universal conditional statements, this one's a little sneakier. So we are going to flip the quantifier. Instead of a comma, we're going to replace that with such that. But instead of P implies Q, we're going to say P of X and not Q of X. All right, so we have to be careful with this one. All right, that's the only tricky one that doesn't necessarily follow the pattern of the other two. All right, so let's take a look at a number of examples to which all we're going to do is we're going to take a look at either a universal statement, an existential statement, or a conditional statement. And we're going to rewrite it in symbols, just like we did before. We're going to rewrite the negation in symbols, and then we're going to write the negation in an English sentence. All right, so let's start off with an easy one. All birds can fly. All right, so symbolically, we can say that for all x in the domain of birds, x can fly. Right, so that's an easy one. The negation. Now remember, for the negation, what we're going to do is we're going to flip the symbols. So we're going to say there exists x in birds. Anytime we have a comma, we're going to replace that with a such that. And then we're going to negate the predicate, which in this case, x cannot fly, would be the correct way to write that. Or so x can not fly, or x does not fly, right? Something of that nature. Right? And then finally, if we want to write that in an English sentence, so we could just say some birds cannot fly. So some birds cannot fly. All right. So that's a pretty easy one. Now, the next one that we have for letter B is that we want to try to write there exist engineers who are good at math. All right. So symbolically, we can write there exists X in engineers such that X is good at math, or X are good at math. Let's hope so. Now the negation, what we're going to do is we're going to flip the quantifier, and we're going to say for all X in the same domain, which is still engineers, we're going to have a comma instead of such that, and we're going to say X are not good at math. All right. And then finally, if we want to write the negation of this sentence in an English sentence, we're just going to say all engineers are not good at math. So all engineers are not good at math. Right? And that's probably not necessarily a good thing. All right, so hopefully that makes sense for everybody so far. Right? So the last one that we have is this universal conditional statement. For all x in D, P of x implies Q of x. And what we want to do is we want to write that using symbols, write the negation using symbols, and then we want to write the negation in an English sentence. All right, so for all students, if you are a computer science major, then you must take assembly programming. So using symbols, we're going to say for all x in students, we're going to say if you are a computer science major, then you must take assembly programming. Okay. Now we have to be careful on the negation. Okay, so the negation using symbols, we're still going to flip the quantifier. So there exists X in students. We're going to take the comma and we're going to say that that's going to be such that. All right, but it's not a conditional statement anymore. All right, so notice that the negation right here does not contain if then, such that you must, such that you are a computer science major and you must not take assembly programming. All right. And then finally, if you want to write the negation, you could say there are students. So we could say, or there exists, something like that. So there exist students such that they are computer science majors and must not take assembly programming. All right, so a little bit drawn out, but that's how we're going to have to go through and do these. All right, so hopefully that makes sense to how we're going to go through and do the negations of these. All right, and negations aren't too difficult, but the best piece of advice I can give for you is to be able to memorize these forms. All right, so these are the forms that you want to make sure you have memorized, so that way you can just do it really quickly. And later in the course, we're going to have to write the negations of statements to be able to prove or disprove them. All right, so this is sort of building up to that point. All right, earlier in the course, we took a look at the idea of the inverse, converse, and contrapositive. And just to remind you about what those are, the inverse, and let's say we have P implies Q, right? So the inverse was not P implies not Q. Remember that the converse was that Q implies P, and we had the contrapositive, and the contrapositive was not Q implies not P, right? So we're going to have to remember those forms to be able to write these universal conditional statements and write the inverse, converse, and contrapositive. And you might recall that only the contrapositive is logically equivalent to the original statement, right? That's important because later in the course, when we do proof, we may have to prove something by using the contrapositive, right? So keep that in mind. So for all real numbers x, if x squared is greater than or equal to 1, then x is greater than 0. All right, so let's start by writing the converse of this. Okay, so the converse is for all real numbers, and I'll just write it out this time since it's the first time we're doing this. So for all real numbers x, if x is greater than 0. Okay, so what we're doing is we're taking the conclusion and we're writing it as the antecedent. So if x is greater than 0, then x squared is greater than or equal to 1. Okay. For the inverse, for all real numbers x, now remember the inverse flips the two statements and it just negates them. Excuse me, it just negates the two. So we're going to say if x squared is less than 1. All right, so when we flip this and negate it, it's going to be x squared less than 1, not less than or equal to. Then x is less than or equal to 0. All right, so be careful with your inverse. All right, if it's not inclusive, you make it inclusive. If it is inclusive, you make it exclusive, and then you flip whatever the inequality symbol is around. Now, finally, for the contrapositive, we're just going to basically flip the conclusion and the antecedent of the inverse, and we're going to say for the contrapositive that for all real numbers x, if x is less than or equal to 0, then x squared is less than 1. All right. And so that's our inverse, converse, and contrapositive for our universal conditional statements, at least for the first one. Okay. Now, for the second one, this one we have to be, again, careful of because there contains an opportunity for us to make a mistake by forgetting some of our rules of logic, right? And the second one says that for all animals x, if x is a dog, then x has a tail and x has paws, all right? So let's start with the converse. The converse says we're still going to keep the domain, okay? So for all animals x, or we could just say for all animals x, and then all we're going to do is we're going to flip the conclusion and the antecedent. So we're going to say if x has a tail and x has paws, then x is a dog. Now, for the inverse, we have to be careful, and I'm going to write it incorrectly first, and then I'll write it correctly. So we're going to say for all animals x, right? And remember, inverse just takes the negation of the antecedent and predicate. So if x is not a dog, then x does not have a tail, and x does not have paws. And this is almost correct, right? The only thing that unfortunately makes it incorrect is that we forgot to change one word in here, all right? And you might recall that De Morgan's law says that if you take the negation of any sort of quantifier that contains an and or an or, you have to flip that statement around. So instead of and, you have to flip that to or, all right? So remember, we have an and here. If we take the negation of this sentence or this statement, so if we say not tail, paws, there will be not tail or not paws. All right, so we have to be careful with that. All right, so don't forget about that when you're doing your exam or when you're doing your assignment. Contrapositive, we have to do the same thing. Right? And for our contrapositive, we are going to say for all animals x, if x does not have a tail, or x does not have paws, okay, and again, make sure to flip that quantifier because we're negating a compound statement, or x does not have paws, then x is not a dog. All right, so just utilizing some of our logic and then also making sure that we understand the inverse, converse, and contrapositive. Right. So that takes care of everything for singular quantifiers. Now, in the next section, we're going to take a look at multiple quantifiers. So what happens if you have a statement with the existential as well as the universal quantifier within it? How do we write that? And then also, how do we negate